arrays are basically, as you can see in this image here, arrays are going to be your data structure for storing multiple values of the same type. So basically what they are is just like a bunch of containers next to each other. Basically in memory, they're even adjacent to each other memory wise. For example, if we're storing like integers, we know for sure that an integer is going to take like, I don't know, 8 bytes or 4 bytes. I think it's 8 bytes in Java. So for example, when we say we need an array of 100 elements, Java is just going to do like, okay, here you go, memory location, this number or whatever number, whatever memory location it wants to give us. And then the next 100 times 8, locations are going to be reserved for our array, So basically this variable a just points to the beginning of an array. And then once we want to access like 7th or 157th element, we just have the, we can calculate where that one is in memory. I mean, Java does all of that for us, of course, we don't have to do anything, but it basically works like that. So it's really fast. When you want some element, like 10th element, it's almost it's instantaneous because it can just calculate the location of that element and access it. Okay, so when we're there's, of course, these are the indices, or that's the that's the plural of indices, right, in English. But index is the location of the element in the array. So that's like, it starts at 0, as you can see in this image. Like if we have some elements, the first element is going to be at location 0, and then the next one is going to be at location 1, 2, and so on, up to the size, whichever the size is. Okay, so when we're creating an array, we need to immediately specify how many elements in that array, because Java needs to prepare, like just to allocate that many memory spaces, So we have declared the array here. We can just say now a is new int of, and now we have to specify how many elements it'll have, So basically by using this new word, we're saying, okay, we want to allocate 12 memory locations for integers, and that's going to be our array A. Of course, all of this could have been done in one line as well, but it's just sometimes we're going to declare arrays and immediately, immediately initialize them, and we don't have to do that. We can do it in 2 different lines. For example, we can like ask the user for input, and that's something that we are going to be doing throughout this class. We're going to be asking the user, hey, how many elements do you want to have? Then he will input some number, and then we will, then declare the array of that many elements, and then we will fill it up and do all kinds of things with arrays. So that's about it for declaring the arrays. Of course, they can be of any other type, any type that you can think of. You can have an array of that. So yeah, let's have doubles, and that's going to be equal to new double array of 99 and 88 elements. Of course, this has to be a whole number. You cannot have like 88.2 elements. That makes sense. I mean, it cannot, it doesn't complain about a negative, but it's just giving you a warning, but that doesn't make sense. So it must be a positive integer here. Okay, so yeah, we can have a string array as well. We can have multiple names, for example, of people there, or we will see later, you can have an array of basically any type. So let's call this names. And now let me show you another alternative way of declaring an array. That's if you want, wait, let me back up a little bit. So now, when we have declared an array, for example, we have an array A and it's 12 integers, and we have an array called doubles, or we can call it numbers or whatever, that makes slightly more sense. Now, how do we access one particular value of this array? Well, using the variable name. What would happen if I just tried to print out A? Well, that doesn't really make sense, because A is an array. You cannot print out an array. You can print it out, but let's just run this, see what we get. It will not be nice, because it'll just, oh, it ran the wrong program, because as you can see here, it ran whatever, and it didn't run this one. So we need to click here, run. Okay, so it printed something out, which is really ugly and doesn't look like anything that we wanted to see. It's basically, we are printing, this is basically probably the memory location of this variable. It's not smart like that to know to print this, like, I don't know, we would expect something like if the numbers are 0, give me something like this, give me 12 zeros. But it doesn't know how to do that here, because A is of type int array. So, I mean, it just doesn't print it out. But let's try to print out the 0th element of this. This is how you access one element, by the way. You specify the name of the variable, and then inside of these square brackets, you specify the index of that element. So if we want the 5th number, the 9th number, and so on, let's just first assign something, just so we can see. A of 9 equals 5, meaning assigned to the 9th, or basically 10th position, because it starts off at 0, so positions are 0, 1. Let me just make this be like a smaller number so I can write it all out. Here now it's complaining because it's like array index out of bounds. The program will crash if your index is 9 and there's only 5 elements. I mean, that makes sense. We will see that later as well. We will make some mistakes on purpose just to see, when it crashes. But now let's do like A of 3, and the indexes for this array, because it has 5 elements, are going to be 0, 1, 2, 3, and 4. So if I try to assign A of 5, it's giving me a warning here. This will crash. If we run this, it'll just crash because it says index out of bounds exception, index 5 out of bounds for length 5. Well, as we said, this would make sense for us because in our heads we start with 1, but in programming the indices always start with 0. So it's from 0 up to the length minus 1. If the length is 5, the last index is 5 minus 1. So be careful about that. And yeah, let's just assign to the 4th element, or the element at index 3, something. And here as well, let's just print that out. Run. And you can see it's a 5. Now let's print out something I haven't assigned, just to see what happens there. It'll be a 0 because it just defaults to 0, right? Because, I mean, Java just fills out the whole array with zeros. When you declare an array of length of 5, it just fills out all the places with 0 because that's the default value for integer. If we created, for example, Boolean array called, I don't know, indicators that indicate something equals new Boolean array of size 3. And now if I were to print out indicators of 0, it would just, here it says it's always false. That's just a warning. When something is like orange like this, that's just IntelliJ trying to tell you, hey, you're not doing something properly, because like this doesn't do anything, but it's just for demonstrating purposes. Yeah, the thing is, it gives a runtime error because it doesn't really know. I mean, it could know that I put like 7 here. You can see that IntelliJ knows, but Java compiler doesn't really know, because you could have put a variable here called b, and b could have been calculated somewhere else, So basically, I mean, you can see that IntelliJ knows that this is going to be out of bounds, but it still does let you compile, even though it's going to throw a runtime exception, Okay, so yeah, and you can see my point about the indicators was that all the fields are going to be false, because false is the default value for Boolean, right? For double, it would be 0.0. I don't know, for float, it would also be 0.0. So yeah, okay. And what would the default value be for string? String names equals new string of 3. And what if we try to print out names of 0? Well, it'll be null. Null is a special value. We will talk about null a lot in the future lessons, but I just wanted to show you null because you can see string is not colored orange. That's the thing that you can immediately see. Int, double, Boolean, float, they're all colored orange in IntelliJ. That tells you something. That means like string is some kind of a more special type, and it starts with an uppercase letter. So, oh my God, somebody's honking in the background. So sorry about that. The string is some kind of a special type, and we will talk about that. That's like an object type. These are primitive types, and the only reason these primitive types have their default value set like this, and object types have null as their default value. I just wanted, yeah, null means a lack of value. Basically, there's no value. A value wasn't assigned yet for object types. We'll talk about that when we get to objects. I just wanted to show you real quick that, you know, the default value for string is null, just so you're not confused if you stumble upon it on your own. Okay, so here you can see that, of course, we can do anything we want with these numbers. We can say int sum equals, I don't know, a of 0 plus a of 1. We can do all kinds of things. And now I'll just get rid of these. I'll leave this one. Okay, sum. And if we run this, yeah, it's 0. Why? Well, because a of 0 and a of 1 are 0. But if I just give them some values before that, so a of 1, a of 0, let's make it 15 and 5, doesn't matter, and run this, Shift F10 for running. And now you can see it's 20, it's 15 plus 5. Okay, so we can manipulate these values just like any other values. They're just basically variables, but this is the way that you access them, you know. Okay, so now what do you think? I mean, the last lesson we worked with loops. So as you can probably imagine, loops link up really well with arrays. I mean, how to print out all the numbers from some array. Well, we will just do that with a loop now. And let's just create a for loop. And what's the ending condition here? How long do we go? Well, there's a special thing that the array has that's called length. Yeah, array.length. And do we go to length or length minus 1 here? That's my question to you. Yeah, the answer is length because it's less than. If we want to go less than or equal, we can go to length minus 1. Of course, both are correct, but it's just easier to write it this way, you know. So now let's just do system out print line. Let me just use the new shortcut that I learned, sout tv. Okay, it didn't really guess what I was trying to do, but yeah, maybe if I start typing in this square, oh my God, this is amazing. As you can see, what I'm typing here gets typed into the string. Oh my God, IntelliJ is so awesome. Yeah, we want to print out a of what? Of I, right? Because I is our runner, you know, our variable. So we'll basically be printing, but this will be I. I want this to be a number. So how do we do that? Well, we will just do it like this. Okay, what does this mean? Well, I'm basically saying concatenate this and then whatever is inside of I, and then this, and you know, and then just, you know, concatenate the actual value of I. So let me just get rid of this. We don't need that. We don't need this either. Okay, let's run. Okay, so it's 15, 5, 0, 5, 0. Why? Well, because a of 3, we have given it the value 5. You know, the others we haven't given any value to, and these two we have. So yeah, now let's create a small program that would calculate the sum of our array. I mean, that should be easy. So let's do int sum. And one important thing that I want to point out is we declare sum here because we need it to not change with every iteration, you know. We just want to add on to it. If I declare sum here, it would just not work because it would get, you know, reset to 0 every time. So sum plus equals a of I, and at the end we just want to print out the sum. And it's 25. These are, yeah, the only 3 numbers that we have declared. One thing that I want to mention as well, when we're declaring an array, this is how you declare an array of some length, but you can also declare like a static array. Let's do that by just giving all the numbers immediately that are going to be, I mean, all the values immediately. So let's do that. It's like array b equals, and then you use these curlies and then basically just write all the numbers that are going to be inside of that array. This is another way of doing it. You know, if you know your numbers beforehand, I mean, sometimes you will, sometimes you won't. We will probably use this a lot for testing our programs. We will just, you know, invent some arrays for testing, some good ones to make our program work or not work properly. So basically, this is just how you declare it. You know, you can add as many numbers as you want. And now if we, for example, I'll just comment the sum. I don't know. I mean, I might get rid of it. You know how to write a sum. It's really simple. I just wanted to show you, for example, we can print out the length of B. So B dot length is going to be 1, 2, 3, 4, 5, 6, you know. So it's basically the same as saying B equals new int of 6 like this, and then filling up each number by hand. This is just a shorter version of writing that, you know, if you know your numbers at the start. If you don't, you have to basically, I mean, declare an array. So now let's do that. I'm going to get rid of basically all of this. Let's try to get some input from the user. I mean, let's try to, I don't know, calculate the sum of some numbers that the user has entered. That's new scanner system.in. Okay, so now let's ask the user s out, enter the length, and we will do int n, because n is usually used. We can use length as well, but n is also commonly used for the length of something. I don't know why, probably because it's n like for natural numbers, I think. Length equals scanner.next int. And let's make our program even nicer now. Let's just say, how do we make the user enter the length as a positive number, but just like make him enter numbers as long as he's not entered the positive one? How would we do that? The easiest way to do that? Yeah, which loop? Which while loop? My point was basically, I thought like a couple of days ago, I thought of a good example to do a do while, you know, a do while that never gets any credit in life because it's basically useless, but here it's actually useful. You will see why. Length equals scanner next int, while make him do that while length is less than 0. And you can see here that this makes sense because we want to run this at least once, but we want to run it many, many times if he's made a mistake. The alternative to this would have been, you know, having this code and then saying while length less than 0, basically the same code, you know. So these two would be the same, you know. Like make him enter once without a loop, and then if he has entered a negative value, then we say, now you're never exiting the loop until you give us a proper value. But this is a good example of when a do while is actually useful. This just looks a little nicer. I mean, it's less lines of code. You never want to have like 2 repeating lines of code like this. They're just probably ugly. It could have been done better, probably. Of course, both work, both are fine, but I'm just saying, you know, a good example of when to use do while. So while the length is less than 0, while he keeps messing up, we are going to loop through. But if he never messes up, if he just enters 10 on the first try, it's just going to get run once and, you know, exit. So yeah, I'm pretty happy about this example that I thought of about do while, because I don't know if I've seen it in the last 5 years or something ever. So yeah. While his length is improper, we're gonna make him enter again, and once he finally enters something normal, we're gonna create an int called array, sorry, numbers equals new int of length. And what do we do? Well, now inside of a for loop we can, or inside of a while loop, I mean, but for loops are basically made for arrays because you have this I. In a while loop, you would have to create your own variable. You know, here it comes with the variable. You know, basically till numbers.length. We could have used the length variable or the numbers.length, but it's always better to use the actual length of an array. Like this can be changed somewhere. I can literally say length plus, or I mean, I wouldn't do this, but the thing is, if you use length as the variable here, who knows what that is later used for, somebody's changed it or something. If you use the length of the array, that's always the safest option, you know. Okay, so now we need to tell the user enter a number, and then when he enters, we're going to say int number, or num for short, equals scanner.next int. And we can even modify the message enter 5th number, you know, like enter ith number. Let's do that. Enter number. Let's make the message like enter number, and then we're going to add 1 here. Plus I plus 1. We want to make it really nice because we don't want to tell the user enter number 0, enter number 1. We want to tell him enter number 1, enter number 2, and so on. You know, it's just I plus 1. So it's nicer for the user to look at. Of course, we know that we're going to be saving that at position 0, but the end user doesn't have to know programming. He doesn't know that, right? So what are we doing here? Well, we're saying numbers of I equals num. We're saving whatever the user has input, like his input some value, we're saving that where? Well, at the current location, the current location being I, right? Okay, so here now it's probably complaining because, yeah, we're writing but never reading, you know, it's so smart.